In today's session, we'll be looking at the arithmetic operators, the relational operators, and the logical operators. So at the end of the session, the learner will be able to state the operators that are used in programming, and these are the arithmetic operators, the relational operators, and the logical operators. Then we'll be looking at the truth table for the NOR operator. Then we'll be giving you an example of the NOR operator. So the three types of operators that are used in programming are arithmetic operators, relational operators, and logical operators. Or the first one that we'll be looking at today is the arithmetic operators. So the arithmetic operators that are used in programming are addition, subtraction, multiplication, and division. These are the symbols that you use in the programming of your solutions. So you wouldn't use a mathematical symbol for the division symbol that you use in math. You use this symbol here. So for example, we have sum equal to num1 plus num2. Then we have discount equal total minus discount. Then we have total is equal to units times multiplied by 4. And in the average, we have total divided by 3. So these are the examples for the arithmetic operators. Relational operators. In programming, relational operators are special symbols used to compare two values and determine if a specific relationship between them is true or false. They control the flow of the program, especially in conditional statements and loops. So the relational operators are equal to, greater than, less than, greater than or equal to, less than or equal to, not equal to, and this is also another way to represent not equal to. So here we're going to show you an example for each of them. So here we have the operator equal to, the name of it is equal to, and the example is if lunch money is equal to 500, then output you can buy a large lunch. This is another way to represent equal to. So the similar example will be used if lunch money is equal to 500, then print output you can buy a large lunch. Then we have greater than, and the example is if A is greater than B. We have less than, and the example is if A is less than B. We have greater than or equal to. So we have, and as an example, A is greater than or equal to B. Then here we have less than or equal to, and here we have the example. If A is less than or equal to B, then we would do an action, and we have not equal to. So here's the example. If A is not equal to B, then we could perform an instruction, and this is another way to write not equal to. Logical operators are used in algorithms for decision making and to control the flow of logic in programming. Logical operators. The first logical operator that we're looking on is the AND operator, and here's the example, A and B, and the meaning is both statements are true. We have OR, so A or B, at least one statement, A or B is true. We have not, an example is not A, statement A is not true. Then we have NOR, which is not OR. And the example is A nor B. And the meaning is if both statements are false, the NOR operator returns true. The NOR operation is basically the negation of the OR operation. If both statements are true or either of the statements is true, the NOR operation returns false. We are looking at the truth table for the NOR operator. I'm going to use the truth table to further explain the concept that I showed you in the previous slide, which is a NOR operator. So here the truth table shows the values for the input Z, the input W, and the output using the NOR operator, and the output Z NOR W. So 0 represents false, 1 represents true in this truth table. So we have the input in today's video is Z, the input is W, and the output using the NOR operator is Z NOR W. So if we have the input being 0 for Z, the input being 0 for W, the output, based on what I explained in the previous slide, would be 1. So here we have another scenario. We have 0 as the input for Z, 1 for the input for W, and the output for using the NOR operator for Z NOR W, the output would be 0. Here we have another situation where the input for Z is 1, the input for W is 0, the output Z NOR W would be 0. And here we have the input for Z is 1, the input for W is 1, and the output Z NOR W will be 0. So this is explaining what we discussed right here in the previous slide. All right, I'm going to give you an example for the NOR operator. Suppose you have a light that is controlled by 2 switches. The light turns on, which is represented by output being 1, if the 2 switches are off, right? Which is the inputs are 0. The light is turned off, which is represented by a 0, if the 2 switches are on, which are represented by a 1. The lights is turned off, which is represented by the output being 0, if either switch is on and the input would be 1, as explained in this truth table. So in today's session, we looked at the 3 types of operators that are used in programming, and these are the arithmetic operators, relational operators, logical operators. We looked at the truth table for the NOR operator, and we looked at an example for the NOR operator. So in today's video, we looked at the operators that are used in programming. In the next video, we'll be looking at the truth tables that are used in programming. Please take care until then. Bye. Thanks for watching the video, and don't forget to subscribe, hit the notification bell, like, comment, and share.